So, if you're making that jump from data science into an MLOps role, you already know this, right? A model's accuracy, that's only half the battle. The other half is being able to explain its decisions. And that's what we're doing today. We're going to crack open that black box of model explainability and really see how you can build AI systems that aren't just powerful, but are actually trustworthy. I mean, we've all been there, haven't we? Your model is hitting like 99% accuracy in testing. You're feeling great. But then in production, it just spits out this totally bizarre prediction, and you have no idea how to justify it. You know, that moment isn't just frustrating. In a live system, that's a critical failure. A decision you can't explain, that's a liability you just can't afford to have. So the answer here is explainability. It's really just the practice of taking a model's super complex internal logic and translating it into something that we as humans can actually understand. We're not just building models anymore, we're trying to give them a voice so they can tell us why they do what they do. All right, so here's our game plan for today. First up, we'll talk about why opening that black box is totally non-negotiable. Then we'll get into the two main ways of looking at it: local versus global explanations. After that, we're going to get practical with a really cool tool called SHaP. And finally, we'll wrap up by looking at the real-world hurdles you're going to face and, the huge impact of getting this stuff right. Okay, let's dive in. Why is opening the black box so critical? Well, for an ML engineer, for you, this isn't some academic thought experiment. It's a core requirement for building robust systems that people can actually trust and, deploy with confidence. You see, explainability isn't just about one thing. It actually solves four really big problems for us. First, it builds trust. Your stakeholders stop seeing your model as this unpredictable magic box. Second, it's hands down your best debugging tool when a prediction goes haywire. Third, and this is huge, it's your main line of defense for hunting down and mitigating hidden bias. And finally, it ensures compliance, because let's be real, in a lot of fields, the model told me so just isn't going to cut it as a legal defense. And this all leads us to, well, a fundamental tension in machine learning. It's this classic trade-off, right? On one hand, we absolutely crave the raw power of these super complex models, but they're total black boxes. On the other hand, we love the transparency of simple models, but they often just don't have the accuracy we need. So the goal in MLOps isn't to pick a side. It's to find the tools that let us get the best of both worlds, getting that top-tier performance and the transparency to back it up. Okay, so how do we actually start making these powerful models transparent? Well, the first step is understanding that explainability isn't just one single action. It's a process that really operates on two different levels or scopes, local and global. And knowing which lens to use and when is the absolute key to getting meaningful answers from your model. So here's the breakdown. Think of local explainability like a detective investigating a single crime scene. You're asking, why was this specific customer's loan denied? You're focused on all the tiny details of one outcome. Then you have global explainability. This is more like the police chief looking at the crime stats for the whole city. You're asking, overall, what features are the most important for our model's decisions in general? So one gives you that deep dive, the other gives you the big picture. And this is so important to remember. These two methods aren't competing with each other. They're partners. You absolutely need that global view to make sure your model's overall strategy is solid. But you also need that local view to audit the individual decisions that are impacting real people. You really can't have a complete picture without both. All right, theory time is over. Let's get down to implementation. As an ML engineer, how do you actually do this stuff? We're going to look at one of the most powerful tools out there, SHaP. The easiest way to think about it is as a method that comes from game theory. And what it does is it fairly figures out how much each feature contributed to a specific prediction. Pretty cool, right? So the process is basically a three-step mission. Step 1, you run explain model. Think of this as your satellite view, giving you that global feature importance, the big picture. Step 2, you deploy explain samples. This is like sending in the ground team, using SHaP to get that nitty-gritty local explanation for specific cases. And finally, step 3 is the explanations job. This is mission control. It runs both of those jobs and then neatly packages all that intelligence into artifacts that you can actually use. So why go through all this trouble? Why run this job? Because it gives you actionable intelligence. These artifacts it spits out, that's what you're going to use to audit your model's logic with domain experts. It's what you'll use to hunt for hidden bias. It's how you generate those clean, clear visuals for stakeholders. Seriously, This isn't some optional side quest. This is how you embed explainability right into the core of your MLOps lifecycle. Okay, now for a quick reality check. These tools are incredibly powerful, no doubt about it, but they are not magic wands. As engineers, we have to be really smart about their limitations and truly understand the trade-offs we're making every time we use them. You're probably going to run into 4 common hurdles. First, this stuff can be computationally expensive, so you have to be strategic about when you run it. Second, the outputs can be easily misinterpreted. Always remember, feature importance is not the same thing as causation. Third, you'll hit that classic fidelity versus interpretability dilemma. Sometimes the most accurate explanation is just way too complex to be useful. And honestly, the biggest danger of all? Using these tools to just explain away a bad model's behavior instead of actually fixing the root problem. So with all those challenges, you might be asking, why even push through? Well, because in sectors like banking, healthcare, and criminal justice, it's just not a choice. When an algorithm has the power to decide who gets a loan, who gets a life-saving treatment, or who gets parole, explainability stops being a nice-to-have technical feature. It becomes a fundamental, non-negotiable requirement for accountability and basic fairness. And that really brings us to the final and most crucial question you should be asking yourself every single time you deploy a model. Are you building a trusted partner, something that can be audited, questioned, and understood? Or are you building an opaque oracle that just demands blind faith? Ultimately, that choice and that responsibility is yours.